This conference will now be recorded.
Right. So what do you know about exception handling? Do you have any idea? Why do we need this? What is exception handling? Okay. So to understand the exception handling, first we should understand about exception. So what is an exception? What is an exception and how do we define an exception? So do you have any idea? So it is the most important thing. Without knowing exception handling, you cannot work. It's part of the development. Do you have any idea about this? No? All right. So what is an exception? Okay. So some people says error, but not really. Okay. Exception is different from an error. Okay. We'll talk about that. Okay. Let's understand first about the exception. What is an exception? It is something like so your code, whatever code you have written, that leads to an exception sometimes. Okay, there could be multiple reasons. Okay, there could be multiple reasons. For example, you are traveling from one place to another place. Okay, so just you are traveling from one place to another place by your own car. Okay, so you started your journey. You started your journey from one place to another place. Okay, you are just traveling. So while traveling, okay, so your car is, yeah, in good condition, but who knows the situations, like, okay, so anything can happen, right, during the journey. So maybe like while traveling unexpectedly, okay, unexpectedly, so maybe it get repaired, or maybe your car tire get punctured, or your engine may fail, right? So there could be different things might happen that we really don't know, right? Or it need not to be also, okay, or without having any issues you can happily you can reach your destination. But there are cases, okay, so some unwanted, unexpected things can happen during your journey, right? So in such cases, like that's what unexpected thing, that is what unexpected thing. So okay, so tire puncture, okay, that is what unexpected thing. Okay, that could happen, right? That is unexpected thing that happen, and it disturbs your journey. Okay, so what do you do? Of course you will change your okay tire, and you will fix that problem, and you will start your journey. You will continue your journey, right? Or else, like if your car got repaired and it takes more time, and you have to uh, go on a bit urgent, then what do you do? Like you can take some alternative vehicle and you can start your journey. Okay, just you can leave that car and you can take some alternative vehicle and you can start your journey and you can reach your destination. This is what alternative, some alternative, you are going with some alternative, right? So either you can go by on your own car by repairing it, or you can take some alternative vehicle and you can start your journey. Okay, when some unexpected, unwanted experiences are happening, right? the similar way the similar way when you are writing a code, similar way when you are writing code, number of lines of code, okay, so these logics whatever you wrote, that works well for few scenarios, that works well for few scenarios. meaning that for the input to data. So if you keep some input, okay, it works well in your testing, and it is passed in testing also, and it went to live environment, it went to production environment, and there, so lakhs of users uh, accessing your application, okay, millions of or billions of users, depends on your application score. Billions of users are accessing your application, and the same logic, okay, is going to execute for all these particular users. Then, so they, as the users are different users, they may give different kind of input to data as per their scenario, right? And this logic might fail for a couple of scenarios, depends on the input to data. Okay, so that's what, it all depends on the user input. And here also, your journey depends on your route, or maybe time, or different factors, like it, your tire got punctured, or it got trouble. There could be different reasons. Okay, so here is the case, like your code is also may not work for certain scenarios, for different users. For few users might work, for few users it might not work. So that is what unexpected. So we did not expect that scenario. So unexpectedly something happened, and our logic is broken, and it leads to, okay, application crash. It leads to application crash, and all of a sudden, so user will experience a page bus. So there is errors, so and so some stack trace, which the end user really don't understand. End users don't understand, right? So that's what we had to handle it. That is what exception, and we need to handle it. Okay, that's what we have to handle it. So how are we going to handle those kind of issues? We'll understand as part of this concept, exception handling. Clear? Okay, so how can we define an exception? Is it is an unexpected or unwanted event that occurs when it occurs during the program execution, of course, the application execution, during the program execution. And what will happen when it occurs? It disrupts the normal journey, right? It disrupts the normal flow of the execution, program execution, and also leads to abnormal termination of the program. It crashes right away. Okay, it comes out of it, and it stops executing your further code. That's what called abnormal termination. Abnormal termination of the program. Abnormal termination of the program. Right. So that is what an exception. Okay. So how can we define an exception? It is an unexpected or unwanted event that occurs during the program execution, and that disrupts the normal flow of program execution, and also also leads to what? Abnormal termination of the program. Abnormal termination of the program. Okay, makes sense, right? So let's see an example. Okay, let's see an example. Okay. Come on. Okay. New class, and just exception example. Okay, I need a main method, so this is what my main method. So here I would want to write a simple logic, very basic logic. Okay, it's a basic division I'm going to write, where I'm going to give the input from my keyboard. Okay, that's where I'm going to read the data from keyboard. Scanner is equal to scanner by passing keyboard to this. Okay, so scanner, I have to import it or not? I need to import it because it's a predefined class available in java.util package, right? So now I can read the numbers. Next integer, I'm going to read the numbers. Next integer. Okay, so number one, this is integer or what? Integer, right? So I'll have to ask user to enter the number. Enter the number one per division. Okay, I'm asking user to enter the number one for the division. So as soon as user enters the data from keyboard, that I'm reading it, okay, from the keyboard, and I'm storing to a variable number one. The similar way, I had to read another number two. So this is where I read number two. Now I'm going to perform division operation. I'm going to perform division operation, right? Okay, so the result might be like, okay, I wanted to print the result directly. Okay, result. Okay, so I just want to do it number one division number two. Okay, this is very basic example that anyone can understand, right? Now see that. Okay, now as a developer, as soon as I write my code, it's my responsibility to test it. Okay, because it's working as expected or not. So I'm executing this. So right, enter the number one for division. Okay, I'm entering value 10. Enter the number two for the division, so I'm entering value 2. The result is what? 5. So as part of my testing, it works well. Okay, let me test one more time for another test case. Okay, another test case. Enter the number one. Okay, 50. Enter the number two. So 20. Okay, yes, I'm getting the value. Okay, 22s are 40, and it's just ignoring that. If you want that also, you have to convert that into floating point value so that you will get it. Okay, right. Now this works well, and I have pushed this code. I have committed this code, and testing team is also tested for a couple of scenarios, and they have passed it. It went to live. Just imagine that the live, so lakhs of users are going to use the division operation as part of their calculations. So all of a sudden, so some user, so without knowing of it, so some user enter a value, Okay, so he entered a value 50, and for the second number he entered a value 2. That is where, so this line is failed. You can see now, exception in thread. What is that exception? Arithmetic exception. Division by 0. And if you have any other lines afterward, okay, you are not going to get those executed. Okay, so if you have any further lines, they will not execute because you have So here can you see done? Now let me run this again with the zero case 10 and 0. Do you see that done is printed here? No, meaning that as soon as it found any exception, okay, so from that particular line it comes out of the program immediately. Okay, immediately. That is what abnormal termination. It's what abnormal termination. It comes out of it by printing a default, okay, a default stack trace. This is what called stack trace. This is what called stack trace. So here you can see where it is broken. Here you can see, click on this, it takes the control to the line. 16 is giving the error, and what is that issue is division by 0. So we are trying to divide a number with the 0 that doesn't result any value. It leads to an exception, and you'll have to handle it. Okay, then how to handle this? How to handle it? That is where to handle. So you'll have to find out the risky code first thing. Okay, you will have to, okay, you will have to find out the risky code. Okay, you are reading you are trying to read the values from the keyboard. Excuse me. Okay, so you'll have to identify. Okay, just you are reading the data from keyboard. Is that really going to give any issue? If you feel that it is going to give issue, you will have to consider this also a risky code. Okay, or if you feel that only the risky code is this much, then okay, you will have to keep that risky code inside a block called try block. You will have to keep that inside a block called try block. Okay, and every try block must be followed by a catch block. Must be followed by a catch block. So you are not allowed to write any other statements in between these try catch blocks. This is sandwich blocks. You are not allowed to write any statement in between try and catch blocks. If you try to keep any line, you are separating it, so you will be getting compiled error saying that try without catch and catch without try. Okay, so must be together, all together. All right. So here, what kind of exception this might give? If you know that for sure, then you write the specific error here. So arithmetic exception here, you are getting arithmetic exception. So now, it's what arithmetic exception. So we are handling that arithmetic exception here. Okay, what will happen here? Like if something goes wrong, so I'm just knowing the user. Hey user, so you are not allowed to do the division operation using a 0. So just I'm giving some message to the user so that he'll understand, oh, I should not pass my number to as 0. Division operation using 0. So using, so what we are asking for the user is number 2, so we'll have to use this one, number 2 value as 0, so that user will understand, oh, number 2 I have given 0 and uh, I should not give that. All right, now if you run this, you can see that enter the number 100, number 220. Of course result is 5 done. Now I'm just going through one more run. So 10 with the 0. Now see, hey user, you are not allowed to do the division operation using number 2 value as 0, and I'm getting done or not. So further code is executing or not. So what is the advantage that we get is, okay, so advantage of handling the exception. What is the advantage? Okay, so we are achieving the program execution to continue and leads to normal termination. Got the point? Instead of abnormal termination from the moment where the exception is raised, it abnormal, it comes out of the program. It doesn't continue to execute further. Instead of that, okay, it continues and it executes the remaining lines of code. Continues and executes remaining lines of code. That's what we're trying to achieve here by handling the exception. And the stack trace is suppressed here. If you look at earlier, we got some stack trace here. Now we suppressed that because we handled it. Okay. If you have any alternative solution, then you can also have it here. Okay. Say so as you are giving 0, so always when the value is 0, okay, I'm going to replace with the default 1 or by default 2. If you have some other logic, okay, that should be like the logic should be valid. Okay, you can implement that so that your application page will never crash. Okay, this is what very important or not. We don't handle this, whatever the stack trace we have seen here, that will be sent out to the browser page, and the user will never understand. He'll not able to understand anything on it. He feel that okay, application is not working, the site is not working, and he gets this kind of things once or twice or a couple of times. He will never visit the website, he will never use that application, right? So it is very important to handle the exceptions. As a programmer, we have to be very clear about the exception handling mechanism. Right, so we understand how to handle the exceptions, so using try and catch blocks, okay. So how to use that? Uses of try catch blocks. Okay, so identify the risky code first. That's what you have to do. Risky code, and place the risky code inside what? Try block. Inside try block. So here you have risky code, and then so you will have to write catch block immediate to that. Okay, now so catch block must be handle the exception raised from the try block, meaning that if the try block is giving arithmetic exception, you will have to handle arithmetic exception. The try block is creating some other exception, say null pointer exception, you will have to handle that null pointer exception. If that is creating another exception, you'll have to handle that another exception. Okay, so the specific exception. So if you don't know what kind of exception it might throw in the when it really working, in that case we'll have to give a specific exception. Okay, in that case we'll have to use a generic exception. Okay, mostly we should go for a specific exception handling. If you are not sure what kind of exceptions it might throw apart from this, then you will have to go for a generic exception. Okay, So note is what? Always we must prefer to handle the exceptions in a specific way. Okay, in a specific way. What is the specific way? So as soon as we discussed here, okay, this is what specific. We are handling arithmetic exception. We are handling arithmetic exception here. This is a specific exception. If we don't know what kind of exceptions that my code leads to, then handle in a generic way. Okay. So what does it mean? The generic way meaning that here, so arithmetic exception, instead of arithmetic exception, so I can handle exception here. I can use exception. Okay, I can place exception. So exception is the superior class for all the exceptions. Okay, it will handle any exception. It will handle any exception. It can be arithmetic exception, it can be array index out of bounds exception, it can be null pointer exception, it can be class cast exception, anything. So this is going to handle. It's what a generic way of handling the exception. Okay. Any questions so far? Right. So this is what we'll have to. So we can handle this way. Generic way. Of course, it works in the same way. Okay. Right. Now let me show you few other things. Okay, say for example I have an array. Okay, so I have an array of elements. Okay, I have an array of elements. Okay, elements, new integer array. Say for example I'm just, let me give some data directly here. Okay, so 10, 20, 30, 40, 50. Okay, this is what my array, and now what I'm going to do is I'm iterating through my array. Okay, I'm iterating through my array, and what is, how many elements I have here? 5 elements. So I'm just I'm the developer, and I'm just doing the code in this way. Okay, I less than 5, I plus plus. Okay, I less than 5, I plus plus, and what I'm doing is I'm going to assign my number 1 value into array value element of I. Okay, I'm just replacing my number with this, and I don't want this number to read from the keyboard. Okay, number. So here what I can do is directly element of I division number. Okay, so the requirement is something like you have group of elements, and you have to perform division operation for all the elements. That's what the requirement. All right, now so this I'm handling this one. Assume that I'm handling this arithmetic exception because I'm doing a division operation, and I know that I'm aware of that. Okay, it throws arithmetic exception, so I'm handling this. Run this. Okay, so okay, enter the number Okay, see that. Enter the number for division 10. Okay, now you can see the result 1 2 3 4 5. This is fine, absolutely fine. Now let me run this again. Enter the number to division. This time user entered 0. Now you can see that. Okay, so hey user, you are not allowed to do the division. Okay, this is absolutely fine because it throwing error. Now what is the size of it? Okay, this will never throw the other exceptions, right? Okay, because when it is iterating through the first index element of 0 itself, it's going to give you error. Now I wanted to access, I just wanted to print all the elements of array elements before my division operation. Just imagine that. Okay, array elements. Okay, array element, array element. Now run this. This is okay. Less than 5. Okay, less than equal to 5. I'm just trying to show you another exception, nothing else. Okay. Element of 0, element of 1. Oh my bad. Here. Okay. Okay. So let me. Now see that. So it leads to another exception. What is that? Array index out of bounds exception. Array index out of bounds exception. So when this exception creates, when you are trying to access, okay, when you are trying to access the array elements out of its range. So how many elements you have? Total 5 elements you have. Okay, total 5 elements. So here 10, 20, 30, 40, 50. So if you observe the index, this is 0 index, this is first index, second index, third index, and fourth index, right? And this you are trying to access element of 0, which is starting from 0, okay? And you are comparing 0 less than or equal to 5. So the condition is what you are doing is less than or equal to 5. So the loop iterations goes for 0th case, first case, second case, third case, and also fourth and fifth. Yes or no? Because 5 less than or equal to 5, true. 5 less than or equal to also true. So what is the index value now? 5. And it goes and it tries to access element of 5. When in the array, when it tries to access element of 5, so does it have that element of 5? It doesn't have, right? So does it have fifth index? No. As index starts from 0, so you have up to 4, index value 4. There is no fifth index value, so that's where you are getting this array index out of boundary. So array index out of bounds exception, which you did not handle it here. Okay, so that is what now. So if you don't know, if you are not sure what kind of exceptions it is going to throw, or it might throw multiple exceptions, then how to handle that? Okay, so there are different ways. By writing another catch block. Okay, so there is a chance of array index out of bounds exception, then you just add this. Okay, this is one approach. Okay, this is one approach, but you will have to find the root cause actually. So here you can see you just handle that. Okay, array elements, it is printed from 10 to 50, yes, and the other case just it comes here and it is set done. And if you look at it is printed the array elements but not printed the result. right? Meaning that, so it bounds that wherever it forms an exception, wherever it uh, creates an exception, so from here it bounds the exception and just directly looks for the corresponding catch block. So it is going to create an index out of bounds exception. It will directly comes to here, like, so it is going to skip this piece of code now. It will skip this piece of code. So wherever the exception creates, from there it will bounce out of it. Okay, it will bounce out of it and it will go to the particular catch block. Okay, so we need to handle these kind of scenarios also. We need to will have to handle, because one piece of code should not leads to stop executing further. If this is really depending upon this piece of code, okay, I mean this is depending on this piece of code, you keep all together, meaning that if this is not went well, then there is no point of executing this. Then this is fine, this is absolutely fine. But if you have a scenario, okay, irrespective of this, whether this piece of code gives an exception or not, I don't mind, but still I wanted to execute this lines of code, then in that case you will have to write the nested try catch blocks. You will have to write nested try catch blocks. Okay, so it just not for this, but this you'll have to write try catch blocks, right? And only this much I wanted to handle it. Any exceptions that may handle that. Okay, now so here I don't need this. Okay, if you look at this now, so try block, okay, inside try block I have another try block. Inside try block I have another try catch block. That is what nested. Inside try block you are defining another try block. Okay, if it has any exceptions, okay, let it suppress here and continue executing this piece of code. Don't stop it, right? So see now how is, just try to understand the difference. And just entering 0, okay, 0 10 20 30 40 50, and it is throwing exception. Why it is printing this? Because still it is coming here. Okay, still it is coming here and continuing it. Okay, let me show you with a different case. Let me enter 2. Okay, now can you see the output result value 5 10 15, all result is printing or not? Okay, now revert this inner try catch block code and see how it works. Now I have only one try and one catch block. So I'm entering value 2. Now see that it's printed array element but not printed this result. It's not going through that because it stopped over there itself. Okay, so because all this piece of code you handle using a single try catch block. But whatever the other case I did, so nested. So I just, okay, this is a risky code, and this piece of code and this piece of code now are not dependent one with another. So even though this code is giving any exception, just suppress that and continue further to execute the remaining lines of code. I'm okay with that. In that case you will have to go for what? Nested try catch blocks. You have to go for nested try catch blocks. It works for this case, it works for, okay, it works well. That is what, okay, exception handling. Okay, anyhow, it requires another session to complete the exception handling. Okay, so today, like, so just I wanted to introduce what is exception, how to handle the exception handling, why to handle exceptions. Okay, and handling mechanism using try catch blocks. Okay, and handling the specific exception, uh, handling using a generic class exception class. Okay, so there is a chart for exception hierarchy. Okay, I'll speak about that also in the next session. Okay, so if you look at arithmetic exception, the superclass is ultimately the exception class. Arithmetic exception is extended by what? Runtime exception, and runtime exception is extended by what? Exception ultimately. That is what. So it's a superclass. So it can handle. So if you use exception instead of arithmetic exception, yes, it still handles arithmetic exception because exception is the superclass for the arithmetic exception. So exception is the superclass for all exception classes. So if you miss any exception, or if you don't know any exception what my code is going to raise, then just keep this, okay, exception. That's all. Okay, we can have multiple catch blocks. Okay, that portion also I'll speak about that also in the next session. Okay, meaning that one try block, okay, one try block can have multiple catch blocks. So can have multiple catch blocks. This is absolutely fine. Okay, this I can keep writing multiple catch blocks. That's fine. Okay, one try block with multiple catch blocks. Okay, right. So you are not allowed to write anything in between try and catch blocks. Okay, so we nested try nesting of try blocks is allowed. Nesting of try blocks is allowed. Okay, and we have seen an example, but I will elaborate more clearly. Okay, so we have nesting of try blocks, and then we have, okay, so we need to speak about different kind of popular exceptions, okay, like null pointer exception, class cast exception, and all exceptions. Okay, then we need to know how to create our own exceptions. That's what called customize exceptions. And we have a concept of try catch finally. Okay, this is what we need to discuss probably tomorrow and day after tomorrow, 2 sessions. I'll speak about these things. Okay, that's where we'll end up the exception handling. Okay, so are you good? Are you followed? Any questions? Let me know. Good. Okay.